Right, I've had a request for an answer about black holes from a guy called Tam who's on my YouTube friends. So, hi Tam, here we go. Right, you said you were arguing with a person, sort of discussing black holes and things with a person. You said that black holes spin, and this person said that they don't spin. And you'd like to hear my take on things, which is great. I like responses, requests. So here we go. Right, you describe space-time as stopping as light bends into a black hole, basically. So if we're viewing light bending, so to speak, as it comes into contact with a black hole, you say, is it not just us getting a look at space-time stopping? Interesting point, you know what I mean? But the thing is, we've got to define what space-time is. I've made another video yesterday about the nature of time and what it might mean, and what it might not mean as well, I suppose. And space-time is an invented concept, I think, really. A physicist invented space-time. It's a way of measuring our observance of the universe, really, I think, because we're observing the universe in a forward sense, or so it seems to consciousness, which is another thing that I talked about yesterday on my other videos on youtube.com/protheory. So basically, like I say, space-time was invented, I think. Space and time are both invented. Space basically means the change that is everything, the universe and everything within it. And time is a forward measurement, and the arrow of time, as I said yesterday, usually goes forwards in physics. In my theory, pro-theory, there's three possibilities. So depending when you observe a black hole, they might spin, they might not spin, or they might be neutral in potential. All three are possible, depending when you observe a black hole. And if you can, if they do exist anyway, which is another point which I'm not going to get into in this video. So basically, what I'm saying is, let's say that you looked at a black hole, there's a black hole over there, and you looked at it and thought, that is definitely spinning. You know, it is definitely spinning. Okay? And you could say it's spinning, someone else might see it spinning, but then when you go back to it, would it still be spinning? Still? I mean, can we guarantee this? You might go back to it 10 million times and it's still spinning, but there's still the possibility, in pure theory, for it not to be spinning, or to be neutral, as in the black hole wouldn't be there, I suppose, which is absolute neutrality means, it doesn't really mean nothing, it means the absence of two opposites. The point between two opposites is that pure neutrality. And that's basically my answer to black holes spinning and stuff. I mean, it's possible, it's not possible, plus neutral. In pure theory, I mean, I'm a philosopher, first and foremost, rather than a physicist. I don't really hold to unchangingly singular concrete things such as space-time exists, humans exist, consciousness exists, you know. Black holes are definitely this singular description. I know full well that somebody else could just say, well, what about the opposite plus neutral to what you just said, the singular thing, and that's the nature of reality, really. I think there's three things, as I've said on many videos before this. I think that's the key to understanding black holes. I mean, black holes are a really, really interesting thing to think about. There's also, if you read A Brief History of Time by Stephen Hawking, one of the first books I've read about physics when I was a child, I suppose. And basically, there's a chapter or a sentence certainly saying black holes ain't so black, if I remember the words correctly anyway. The implication being that if light is being drawn into a black hole, then surely they won't be so black, will they? If there's loads of light around the entry point to the black hole, then light is obviously going to be there, and light is light, isn't it? Light's not black, if you see what I'm saying. I suppose the actual description of a black hole refers to the absence of light, classically speaking, doesn't it? The implication being there's no light able to function. There's no light. If a black hole is stronger than light, which light is assumed to be the strongest speed in the universe, the strongest power in the universe, if you like, the strongest energy. And if a black hole can break that, then it breaks all theories of physics, basically, that are based on the unchanging constant speed of light. That's the basic problem with black holes. So black holes ain't so black, and there's three possibilities. I mean, basically, as I've said in my essay about black holes on protheory.com, in Pro Answers, Physics Answers, black holes, it's a black hole's like an implosion, you see. It's the opposite to an explosion. Really, really simple. As I've said before, there's three possibilities to everything. So black holes can either explode, implode, or be neutral in their potential. Trying to unchangingly prove one of these singular is possible, but also theoretically not possible plus neutral. I know this seems really annoying, but this is pure theoretical thought. That is my interest at the current moment. I hope that answers your question somewhat anyway. I'm going to make some more videos about this as and when I'm able to, and see what else I can say about black holes really. I mean, at the moment it just seems like I'm saying this ridiculous sort of veto opposites and neutral argument, which perhaps I am, I suppose, but this is just getting started. I mean, this is just the beginning to protheory.com and everything else. And once we've laid down the absolute fundamental unit of change, which is 1, 2, 3, negative, positive, neutral, though they're only words to describe these three potentials, but anyway, once we accepted this, I'm hoping that we can move on to the more relative stuff, assuming that humans exist and then seeing what we can see with our senses and stuff, which is also interesting to me, extremely interesting actually. But until we've got the actual absolute fundamental properties of the universe accepted, explained, acknowledged and proven really, I just think we're going to always be arguing, oh, what if such and such, what if such and such, this and that, you know. And thanks very much for watching, okay?